Let me tell you a story. In 2024, an AI agent in Kisumu, Kenya did something incredible. It correctly diagnosed a case of preeclampsia. Now, this agent had it all: memory, tools, a perfectly clear prompt. But then, when it tried to do the most important thing, book an ambulance, the API it was using failed. And the agent, it just silently gave up. The mother didn't get help in time, and you have to ask, why? Why did this happen? Well, it's because the team had built a collection of impressive components, but they hadn't built a complete workflow. So today, we're going deep. We're going to talk about what it actually takes to build an AI agent that is truly unbreakable. This is about moving past the cool tech demos and engineering real, genuine integrity into the systems we're building. This, right here, is the core of what I call Phase 7 of the journey to Master AI, building a complete single-agent workflow.
You know, at my company, SIHA AI, we have this saying that we live by: a workflow is a promise. It's a sacred commitment. It means that when a user, often in a moment of real vulnerability, turns to your system for help, that system will see them all the way through to a resolution. It's not about spitting out an answer, it's about delivering an outcome. That is the fundamental contract between you, the builder, and them, the user. But here's the problem. When that promise is built on a fragile foundation, just a simple chain of components with no resilience, it's not a question of if it will break, but when. So let's dive into exactly why this happens, and more importantly, what we can do to stop it.
I want you to just let that sentence sink in for a second. This is huge. This is the future that so many of us have been working towards, right? An AI agent out in the real world in a clinical setting, making a diagnosis that's notoriously difficult and incredibly time-sensitive. It represents just a monumental leap forward for large language models and their ability to reason over complex medical data. It's a huge win for tool use, for the agent's ability to access and understand information. It's a victory for prompt engineering, for our ability to guide these models to do high-stakes work. On the surface, this should have been a massive success story, a banner headline for how AI can save lives. Everything, it seemed, had worked perfectly.
And this is where the perfect story becomes a tragedy. This is the question that I believe should keep every single AI engineer up at night. If the diagnosis was right, if the tech was so smart, what on earth went wrong? And that question forces us to look past the dazzling performance of the LLM itself. It makes us scrutinize the entire system, the very environment that this intelligence is supposed to operate in. You see, this isn't a question about the model's intelligence. It's a question about the system's integrity. And that's the crucial difference between an agent that is clever and an agent that is dependable. And in the real world, when lives are on the line, dependability is the only thing that matters.
Okay, so let's get right to the heart of the failure. The agent was fully equipped with all the right parts, all the right components. It had memory, so it knew the patient's history. It had tools, in this case the ability to call an SMS API to get an ambulance. And it had a clear prompt, a core mission: protect this mother's health. But here's the thing. Those are just pieces on a chessboard. They're totally useless without the rules of the game, especially the rules for what to do when things go wrong. And the workflow, that's the process that connects all these pieces and is supposed to handle the chaos of the real world. It was brittle. It was fragile. So when one tiny link in that chain, the SMS API, broke, the whole system just collapsed. It didn't retry, it didn't have a plan B, it didn't alert a human, it failed, silently. And in that silence, a life was put in terrible danger. This, right here, is why we have to evolve from just building components to actually orchestrating promises.
So, how do we fix a catastrophic failure like this? Well, I can tell you the answer isn't a bigger language model, or a more clever prompt, or a faster API. The solution is a fundamental shift in how we think about building these systems. We have to start thinking about the very soul of the agent. What is its core purpose? What makes it resilient when things get tough? What ensures that it follows through on its mission, not just when everything is perfect, but especially when things are messy and broken? This is the moment where we have to stop thinking like computer scientists and start acting like systems engineers.
I absolutely love this way of thinking about it because it makes everything so clear. It all comes down to basic grammar. Your components are all nouns. The LLM, the vector database, the API, they're just things. They're static objects sitting there waiting to be used. But an agent's real value isn't defined by what it is, it's defined by what it does. And that is the verb. The workflow is the action. It's the retrying, the falling back, the escalating, the confirming. It's that persistent, relentless action that turns a list of nouns into a meaningful sentence, a complete thought, a fulfilled promise. Without the verb, all you've got is a useless pile of parts. But with the verb, you have a system that actually works.
All right, let's look at this side by side, because this visualizes the entire shift in thinking. On the left, you've got the broken workflow from our story. Step 1, the LLM makes the right call, book an ambulance. Great. Step 2, the tool it tries to use fails. Step 3, nothing. Silence. The end. It is a two-act tragedy of wasted potential. Now, look at the right. This is a complete workflow. This is a system built with integrity. The first two steps are exactly the same. The LLM decides, the tool fails. But instead of just giving up, the workflow, the verb, kicks into high gear. Step 3, it retries. Why? Because a lot of failures are temporary. A quick network blip, a server hiccup. A simple retry can solve a huge number of problems. But what if that fails too? Step 4, the agent falls back to a different tool, maybe a simpler one. It can't use the fancy API, so it uses a basic SMS gateway. What if even that fails? Step 5, it escalates to a human. It recognizes its own limits and dials a nurse directly. And then, and this is absolutely critical, Step 6, it confirms with the user. It closes the loop. It tells them, help is on the way, a nurse is calling you now. This isn't just a longer list of steps. It's a completely different philosophy. It's designing a system to succeed, not just to try.
This right here, this is the workflow contract. This is the promise that we programmed into the very core of our maternal health agent in Nairobi. And let me be clear, this is not just a clever line of code in a prompt. This is a pledge. It is the agent's soul. This one sentence transforms the agent from being a passive tool that just answers questions into an active, relentless advocate for the user. It communicates this deep sense of ownership and responsibility. It says to the user, I'm on your side. My job isn't done until you have what you need or until you tell me to stand down. That is the profound difference between AI that just tries to help and AI that actually delivers. And in high-stakes fields like healthcare or finance, that difference is everything.
Okay, so we're all on board with the philosophy. We understand the why, the absolute moral and practical need for building these resilient systems. So now let's shift gears and get into the how. How do you actually engineer this level of resilience? Well, it's not magic, and it's not about writing an endless nest of if-then statements. It's about following a structured, disciplined process. So let's walk through the 5 non-negotiable stages that have to exist in any complete single-agent workflow.
Let's break this blueprint down. Stage 1. Input interpretation. This is the front door. The agent has to understand not just the literal words a user says, but the deeper meaning, the intent, and crucially, the urgency. A message like, I have a headache and my vision is blurry, isn't just text. It's a potential emergency that has to trigger a high-priority response. Stage 2. Memory retrieval. An agent without memory is an amnesiac. A complete agent reaches back into its memory to get context. It knows, hey, this user's blood pressure was already high 2 weeks ago. That context changes everything. Stage 3. Tool orchestration. And notice, the word is orchestration, not calling. This is where you call your tools, sure, but more importantly, it's where you plan for them to fail. You build in error handling, retry logic, and a clear chain of fallbacks. Stage 4. Synthesis and decision. This is where you bring it all together. The input, the memory, the results from your tools. The agent synthesizes all of it and applies its safety and ethical guardrails to make a reasoned decision. And finally, Stage 5, and this is the golden rule. User confirmation and escalation. You have to close the loop. Tell the user what you've done. And then, you must always give them a clear and easy way to talk to a person. That's how you build trust.
All right, I'm going to let you in on a critical technical secret. This right here is what separates the amateur agent builders from the professionals. A lot of people build their agents as a simple linear script. You know, do A, then do B, then do C. We call this happy path design, and it is absolutely doomed to fail because the real world is messy and never follows the happy path. A truly robust workflow is built as a state machine. Now, don't let the term intimidate you. Just think of it like this. It's not a straight line, it's a map. It has multiple routes to get to the destination. If a tool works, you go down one path. If it fails, you don't crash. You just transition to a different state, like retry or fallback. Every single one of those 5 stages we just talked about needs to be a point on this map with its own escape routes and detours planned out from the very beginning. You have to anticipate chaos.
So let's take this idea even further. What if we could build workflows that are so resilient they feel to the user like they never fail? Well, that requires a very specific mindset and a set of engineering principles we've developed and call the Frugal workflow stack. Now, this stack wasn't dreamed up in some pristine lab in Silicon Valley with perfect internet. It was forged in the fire of necessity, building life-or-death systems in some of the most technologically challenging places on the planet.
This difference in mindset is absolutely everything.
Look, if you're building an app in an environment where you have 5 nines of uptime and super fast internet, it is really easy to forget that things can break. You design for the happy path because, hey, it works 99.999% of the time, but when you're building for a place like Kakamega, where the internet could vanish for hours, you have to completely flip your thinking. You have to start with the assumption that failure is the default state, and success is the rare exception that you have to fight and engineer for. And here's the beautiful thing. That constraint, it doesn't make your systems weaker. It forces you to build something profoundly more robust, more resilient, something anti-fragile that can actually thrive anywhere.
So this is it. This is our Frugal workflow stack. Let's walk through these principles. First, radical error handling. We have a non-negotiable rule. Every tool call must have 3 defined fallbacks. First, you retry. Second, if that fails, you fall back to a simpler tool, like using basic SMS instead of a complex API. Third, if all else fails, you escalate to a human. Always. Second, offline continuity. This is a game changer. If the internet dies mid-workflow, the agent doesn't just crash. It queues the pending actions right there on the device. It saves its state. Then when connectivity comes back, it picks up right where it left off. The user's request is never lost. Third, human in the loop is not an afterthought. It's a core feature. Any important decision requires user confirmation and an easy one-tap way to talk to a person. And fourth, comprehensive monitoring. If a workflow breaks and nobody knows, it's a silent disaster. So we log every single stage. And if a workflow ever truly fails to recover, it immediately sends an alert to an engineer so we can fix it.
And let me tell you, this is not just a theory. Let me give you a real story of this stack in action. In Malawi, we have an agent that helps diagnose tuberculosis. Its main job is to check an API for a patient's lab results. Well, one day that API went down, hard. A broken Happy Path agent would have just said, "Sorry, can't help." But our Frugal workflow kicked in. It automatically triggered its first fallback, an on-device symptom scoring tool. Based on the user's answers, the score came back as high risk. That triggered the next fallback. The agent sent a high-priority SMS directly to the local clinic with the patient's ID. And get this, within 8 minutes, a nurse who got that text was on the phone with the patient to schedule an immediate consultation. No cloud, no complex systems, no drama, just care. That is the real power of designing for failure.
All right, we've gone through the philosophy of the unbreakable workflow, we've laid out the 5-stage framework to build it, and we've talked about the Frugal stack that makes it resilient. Now it's time to make this real for you. Let's move from theory to action. This is your plan for implementing Phase 7 in your own work. This is how you stop just connecting components and start orchestrating promises.
Here are 4 things you can do starting today. First, map the entire user journey. I mean it. Get a whiteboard, and for every step of the process, you have to ask, what happens if this breaks? What is plan B? What is plan C? Be more obsessed with the failure paths than the happy path. Second, architect your agent as a state machine, not a simple script. Use a modern framework that supports this, or just build a robust one yourself. This is the architectural decision that underpins everything. Third, you have to stress test your system in real conditions. Be ruthless. Have a chaos day where you intentionally kill your APIs, unplug the internet, and feed your agent confusing garbage. If your agent ever just gives up on the user, you've found a bug you need to fix. And fourth, embed your ethical handoffs from day one. They are not a feature, they are a requirement. Every workflow has to end with a clear confirmation and an obvious, easy path to human help. This is how you earn trust.
Before any agent we build ever sees the light of day, it has to pass this. This is our sovereign workflow checklist. It's simple, but it's brutally effective. 1. For every critical action, does it handle 3 levels of failure? Retry, fallback, and human. 2. Does it work offline? Can it survive a loss of connectivity without losing the user's intent? 3. Does it always offer a clear path to human escalation? Is there an eject button? And 4. Is every single step auditable? If something goes wrong, can you trace back exactly what happened and why? If you cannot answer a loud, confident yes to all 4 of these questions, your agent is not ready for the real world. Because a workflow that breaks a user's trust isn't just broken, it's dangerous.
Look, at the end of the day, we don't always have the luxury of building things that only kind of work. When a person is relying on your system for something critical, your workflow has to deliver, period. If it can't, it shouldn't be making a promise in the first place. And that means we, as builders, have to adopt a totally different mindset. We have to build with frugality, with resilience, and with human dignity designed into every single step. So I am challenging every engineer, every product manager, every founder who's listening to this. Stop just assembling parts. Stop just connecting components. Start orchestrating integrity. Because the most powerful agent isn't the one with the smartest brain or the fanciest tools. It's the one that never ever leaves the user behind.
All right, if this deep dive was valuable for you, I've just got 3 quick things to ask. 1, please hit that like button. It really does help the platform show this to more people who need to see it. 2, make sure you subscribe and hit that notification bell, because next week, we are diving into Phase 8, creating multi-agent systems, where we take everything we learned today and apply it to entire teams of agents. And 3, check out my explainer on what a real AI engineer actually does. It's already changing how people think about the skills we need in this new world. Thanks so much for joining me. Think deeper, build wiser.